recording has started. I'm going to share. Oh, my deck already got it. So the doc is in there. And I will share my screen. Okay. So announcements. Kept Freeze is Thursday, June 13th. And there's the link for all of you who are curious. And for the first discussion, if we would like to start with stateful set support for updating volume claim templates. Do we have the presenter present?
Yes.
Okay. Would you like to share your screen and present?
Hey, yes.
I'm going to make you co-host temporarily, and I'm going to stop sharing. So you should be able to share your screen.
Okay.
And is your name Hugh?
My name is Hu Weiwen.
Wait,
we are from Alibaba Cloud from China.
Okay. I just want to make sure I pronounce your name correctly.
Hu Weiwen.
Hu Weiwen. Cool. Welcome.
I think we also have some workmates here. Zhao Zeyu is also from Alibaba Cloud, and we are first time here. So nice to meet you.
Nice to meet you as well.
I'm going to share our design of the stateful set support for updating volume claim templates. So let's begin. And here, so let me introduce the background first. Okay. And the background is currently we cannot update the volume claim templates in the stateful set. As a result, but we can update the PVC actually. So if we want to expand the volume currently, we have to execute the kube control patch command manually on every PVC. So this is an ad hoc operation, and we cannot reuse our infrastructure as code pipeline. So there is no something like code review or testing or some rollback or anything. And this is the issue one. And another issue is when we are scaling up, old template is still used to create the new volume claims. And this is obviously not desired. So because we have run our set for some period of time, and we have more data to store, and we cannot create a larger volume, but we have to scale this volume, scale these claims again. This is not desired. So, and we also have some more reasons for why we need to edit the volume claims template. So first one is just introduced. We want to automate the volume expansion operation. And the second one, we now have VAC, which is a volume attribute class. This works like storage class, but it can be updated. This feature is currently alpha. This feature can be used to change the IOPS or bandwidth that is provisioned for the volume. And the third one just introduced, we want to affect the new PVCs created for new replicas. And last two, maybe we also want to update the existing PVCs for some reason, because, for example, we want to switch to new storage provider, or we want to switch to new implementation of the same storage provider. And we need to update the PVC. Okay. Currently, volume claim templates seems to be only thing that we cannot edit in our workload controllers. Okay, so here's our proposal. So the first one is make the stateful set spec dot volume claim templates editable, mutable. So we can just patch anything into the stateful set, the volume claim templates. And the second one, we want to introduce a new field called the volume claim update strategy. That this field works like a per stateful set feature gate. So if it is kept at the default value on delete, this is the current behavior. That is, we only update the PVC if the old PVC is deleted. So we just create a new PVC for it. And here's the new behavior, which is called in place. And this means we update the PVC automatically when we find the template is updated. And so to implement this new strategy, we will need to make some changes to the stateful set controller, and we need to add some PVC reconciliation logics. And we also need some new fields in the status to inform the user about the current status of the PVCs, so that they can know how the expansion or other modification goes. Okay, so how to reconcile the PVCs? And my proposal is just manage the PVCs like how we manage pods. And so we don't do any validation to the templates, just like we don't validate the pod template. For example, the invalid service account name should not cause us fail to update the template. And we can also have multiple revisions and for the PVC, for the claim template and rollback and etc. Many features that's available to pods also available to PVC. So when we want to recreate a pod, we just update the PVC in place. That is, pod is updated by deleting it and create it again with the new configuration, because pod is immutable. But we cannot delete PVC, because delete PVC will remove all the data in it, which is the most thing that we don't want to happen. So we only update the PVC in place. We will never delete a PVC automatically. And when doing rolling update, we will wait for the pod to be ready. And if we are updating the PVC, we instead waiting for the PVC to finish its expansion or modification. So in this way, we can reuse much of the logic for pods to the PVC. So here is the most troublesome part. So what if the PVC cannot be updated? As you know, many fields in the PVC is also immutable. So we cannot guarantee that the PVC can be updated to match the template. So in this case, here's my proposal. In one sentence, that is, skip if it is obvious that the PVC cannot be made compatible to the templates. So this is based on a set of rules which is introduced later. And otherwise, we will try to update the PVC, and if we fail to update it, we block on the failure. So the user will need to intervene to deal with it manually. And so here is the rules. First, the PVC cannot be shrinked, so it can only be expanded. So larger claims is compatible with the smaller template. So if we have larger claims, then we can just keep the PVC as is. And if the PVC and template differs in immutable fields, that obviously we cannot make them compatible. So we just skip these PVCs, and we will discuss this later, more on this later. And if this really happens, user can still update the PVC by deleting the PVC manually. And if the pod is using the PVC, the pod needs to be deleted so that the PVC can be terminated, or it will have a finalizer and cannot be removed. So what if the expansion and modification failed? And for example, we may don't have enough space for the PVC, or we have some permission issue or anything. So if this happens, we just block the rolling update, just like pod is not ready. So we wait for the user to decide what to do. And if possible, we should automatically revert to the previous state if the template is reverted. And this can be done just by kube control rollout undo, hopefully. But this also depends on some alpha features. So maybe it is not possible, but we will try our best. Okay, so here's the second row for the previous slide. What to do when the immutable field differs? So will we block or just skip this PVC? And in the previous slides, I proposed to just skip these PVCs. And of course, we will add some fields in the status so that user can know that some of their PVCs are not updated. They can monitor the status, and if it is not desired, they should take action themselves. But it's also possible that the user just want to update PVC for certain. That is, here is the bonus. So if we introduce another field which is called the volume claim sync strategy, and the new behavior named lockstep, that is, if the user specifies lockstep, we will always update the PVCs first. So that the new pods will not use the PVCs for certain, will not use the old PVCs for certain. So if the immutable fields differs, we then just block the rolling update and waiting for the user to take action. So the user should delete the old PVC manually to unblock and continue the rolling update, or he can just change this strategy fail to async or take some other actions. And this strategy is designed for users who have strong dependencies between pods and volumes. But I don't have such a use case currently. I just think someone may need this. So we may discuss later what strategy that it is more desirable. Okay, so so we already have kept 0, 60, 60, 61, 61 before. And what is the difference? So the previous cap proposed to validate the template, that is only allow the update to the templates that whose storage class allows expansion, and reject if it is not. So, but I don't think this is a good idea. I think this is not a good idea. So, because if we do the validation, then kube control rollout undo, that is very weird. The previous cap proposed just not undo the template update, which seems not a good idea. So, and we are not validating the template for the pod. So I think for consistency, we should not also not validate for the PVC. And the validation is racy. And as just described, the validation depends on the storage class, and we should fetch the storage class in the validation, which for certain is racy. And we don't want to depend on the order that the resources appear in the cluster. So, and we also have a use case that we only want the template to affect the new replicas. So that is make no sense to validate the template, because old one is not updated. So the previous cap also want to allow just allow the update to the field that controls the expansion of the volume. But this cap proposed to allow the update to the whole template, to every field. Okay, so I think, so why I want to do this? Because historically, the claims and templates are already inconsistent. And so this is because currently the PVCs may be created beforehand, maybe before the stateful set is created. And stateful set will just reuse the PVC with the same name. So the templates and the claims are already inconsistent. So it is just not simpler if we don't allow update to other fields. And the new replica use case. So and we also have some other fields that can be updated, and these fields are also enabled in this cap. And we may have more mutable fields in the future. So this cap is more extendable. Okay, that's all. And there are many other details in the cap, which you can check in the GitHub. Okay, yeah.
So I think the reason that we wanted to lift the immutability of the size for the volume claim template in support of resizing volume claims is because from SIG storage, many of the storage providers that integrate with Kubernetes via the CSI have implemented in-place resizing and in-place resizing of the file system, not just at the block level, right? So that is something that could be done and reconciled in place without disrupting the workload. And there's a utility there, like people can actually resize a volume in place in a way that notionally is non-disruptive. I guess when I take a step back and I look at what you're proposing in terms of being able to affect, like the CAP calls it out as in place, but really, if I understand correctly, you're proposing deleting the prior persistent volume claim and then creating a new one, correct?
No, I'm not going to the stateful set controller will not delete an old PVC automatically.
Even during the story 2 migrating between storage providers, so it would create a new PVC for the new storage class, and then the pod would mount that PVC, but the previous PVC would be left standing around.
For this use case, I propose to just waiting for the user to delete the PVC.
Yeah, okay. So you would leave it standing around, and then the rollback would look like when you roll back, you would
And
but
I
how
just
would go ahead.
before the user delete the old PVC, we just stop there and blocking there. And after the user delete the old PVC, so that we can create a new PVC with the same name.
Okay, so the way this would work in practice is you would kubectl apply, modify the volume claim template, update the storage class. The stateful set would do what at that point? What would the resource controller do? It would block until the prior one was deleted?
Yes, I think so.
Okay. And in that case, how could you ever roll back? Because in order to advance, it will require that you delete the existing volume claim, which may not delete the underlying volume depending on the reclaim strategy associated with the PVC, right? But you would definitely delete the PVC altogether, and then it would leave the volume as unbound. And then when you create the new PVC with the new storage type, you're expecting the provisioner to provision a new volume. Like the rollback there seems really complicated, and I guess like when I take a step back, if I'm running like, let's say, a replicated storage system where it's like uniformly replicated, like a relational database management system, if I want to create a new version of it and then, you know, have all of my storage replicated over, why wouldn't I just create a new stateful set with a new volume and then set up like logical replication of the write ahead log or the redo log in order to do that? And then if it's something where it's like Zookeeper or something that is uniformly replicated via consistency protocol like Raft or like multi-Paxos, right? Why wouldn't I just create a stateful set that has observers and then and observers for SCD and Zookeeper are a thing, and then replicate it that way? Like it just seems like using multiple stateful sets might be safer at the end of the day and less error prone and even less manual. Like I'm just not necessarily seeing the automation win. Maybe can you describe the your particular use case so maybe we can understand better how this is going to make life easier for you?
And so first, the the target use case, the main target use case is still the first one, the first three use case. And here, this tool is just the side product that we allow the update of the volume claim templates. That would enable this use case, but we are targeting these three use case. And we have a real use case for this. And we are a cloud provider. So historically, we provide our customer with the flex volume implementation. And now, of course, we got CSI. And we still have a hard time to guide our customers to that is to switch from flex volume to CSI. So if we do have this feature, that is, if we can update the storage class, so it will enable us to use this method to transfer from flex volume to CSI. That is, we can pre-provision the PV with CSI and then update the storage class and then delete the PVC. The underlying data is not affected. Of course, as you say, this way we cannot undo this. We cannot roll back this easily. Yes. Yes.
It also doesn't seem like, so the organize, well, actually, Majek, you go. I'll hold my comment till after.
Yeah, so to build a little bit more on what Ken was saying and to address the problems that you're just mentioning about being able to roll back, whether you're talking about new storage provider or new storage implementations, there is a mechanism that we implemented and we're actually currently GAing, which is called stateful set, which allows you to control starting replica. It's kept 3335. I'll link it in the chat if you're curious. But basically, the goal behind this particular enhancement was to be able and to allow users to create their own external migrator and move from one stateful set over to the other transparently by moving one replica or how many replicas at any given point in time, which would allow you to have a first of all, automating the migration, but also allowing you to have a path in rolling back in case at any point in time the rolling update fails. Going back to the first three topics, I'm very curious, and I'm talking about the volume expansion, the volume attribute class, and basically your three use cases. Why, if you're saying that you're only caring about these three, why not just following up with the KEP 661, which you did mention out, which addresses the three main use cases that you've had. Although one clarification, we actually do validate pod templates when creating. So the reason behind ensuring that the persistent volume claim template is also validated is to ensure that we will not create a stateful set that will be in a perma broken state. So I would strongly try to achieve the same results, especially that the topic has been run through SIG storage and SIG apps. I don't know if others were also involved in the 661 cap. I haven't checked that one, but that seemed like a path of the least resistance and probably something that I would start with. And eventually, if we are seeing additional use cases and eventually need, because the current solutions of the simple expansion and the ability to coordinate the rollout of more sophisticated changes in your stateful set through the to the 3335 cap that I mentioned. Only then I would probably try to figure out and see what are the missing blocks and revisit the problems that you're facing.
One thing that I'm sympathetic to, particularly with changing the volume performance for disaggregated storage, with our model today, because all of the parameters that are to the underlying storage provider are specified by the storage class, there's no way that you can like parameterize a persistent volume claim in and of itself to select a different like performance class if that's a flag, that's a parameter. You can't like parameters don't bubble up to the claim itself. They're strongly associated with the class, and you can't switch the class. So that's something that like, you know, but that being said, like the risk involved, like rewriting the entire storage model in order to allow people to set a flag or provide some numeric, some interfloat or something that allows you to like specify, I would prefer to have like I could actually see that maybe even like as a parameter bubbling up and then using the strategy that's kind of proposed with volume expansion in order to be able to set like the performance characteristics for like throughput for disaggregated storage, as opposed to trying to do this update in place where like it just seems, I mean, at least like I would call out in the drawback sections that it's potentially, you know, like we're saying you need to delete the PVC and block in order to do it. Like for the change provision volume performance, it's not something that we bubble up right now, but like totally amenable to like, hey, this is becoming more relevant, and it's something that like bubbling up that parameter through the storage class into the volume claim is starting to make sense. Like that would be an approach I think is worth looking at. I think for the volume expansion, like we don't want to do it in the way that's being proposed here, if I'm reading this correctly, in that like this is something that we can do in place and safely, right? So like requiring like the disk to get deleted, or I guess, are you saying that the controller should detect that we're only mutating the size and that this particular storage class allows for file systeming, block expansion, and then in that case we do it without actually deleting the PVC, we just modify it, and only when we detect a change in the storage class would we actually say like, okay, well, we're going to block on this until you delete the prior one, and then we'll recreate the other one.
Yes. So I am writing here. So if it's obvious that this cannot be updated, we will just skip that. We will only try to update if we see the PVC seems to be expandable and it looks like it can succeed.
But I guess like how do you detect that? How do you decide that? Right? Like for a resize, you could look at the storage, the storage class and look at if it's expandable. And in that case, you're like, okay, well, I can do this or I can't, and I can return an error. But you could do that at validation time, which I understand by this proposal you're saying is racy. But I mean, I'm not entirely sure I agree with that personally, but I get what you're saying there. For like, would you like would it be like, okay, I will I will not try to do anything if you ask for a storage class that doesn't exist, or like I would just block if the new storage class exists. Like for each thing that's mutable, how would you decide the behavior of the controller?
Yeah, that should be decided case by case. And we only have several of them now. That is only the storage size and the volume attribute class, which is currently alpha, and the labels and annotations. I think we only have these mutable fields.
Okay, so you're saying for labels and annotations, just, yeah, I guess you do need at a minimum for the KEP to call out how you're going to handle each of those, right? Like, and say like, this is the behavior we would expect and these are the use cases. But even then, I'm still a little bit like, this seems very heavyweight and risky relative to starting with the fields that we have a high demand to modify in place and that we can do safely. I see Clayton on here. Clayton, do you have any thoughts?
I have another reason here, and why we are not doing expansion only. Here it says, and what if the claims and templates are already inconsistent when we modify the volume? So if we just allow the storage size to be modified, we still need to consider this case. So in this proposal, I'm going to just skip this case if it is inconsistent in the immutable fields. And if we only allow expansion, and what should we do?
What do you mean by if the claims and templates are already inconsistent?
And for example, the PVCs are created prior to the stateful set. And for example, it has another storage class. The PVC and the templates have different storage class. Then we patch the template to give it a new size, and whether we should expand the claims.
I think if I remember correctly, and I have to go back and review the existing KEP for the expansion, but I believe that's exactly what they would do. Like, so if the user creates the PVCs under the hood manually and then adopts them via the stateful set going through and creating the like just adopting the claims as it creates the pods, and then you patch it, it would just resize the existing claim, presuming that the storage class allows for expansion. So the user would get the modification they asked for, and it would mirror their declarative intent, but it would still be inconsistencies they created declaratively by creating the volume claims manually and then having the stateful set controller adopt them would still be there.
Yeah. So yes. So this is the diverse. So my proposal is to just skip this and don't expand this inconsistent PVCs, because I think this may just surprise the users. The expansion comes with some side effects outside of the Kubernetes. For example, it will introduce extra cost or something else. The one who update the template may not be aware of how the PVCs in the system looks like. So maybe we should not update the PVCs that are inconsistent.
I think that's reasonable feedback. So like if we wanted to modify the existing approach to resizing volume claim templates, like the existing KEP, and say that what we'd really like to do is implement full reconciliation for the persistent volume claim. And in the event that there's a modification to the claim template that causes it to be inconsistent with what was provisioned, we want to block and force users to reconcile it is valid. I think the challenge with that is it breaks the existing semantics in a way that's not compatible. Like, I don't know how I would implement that in a version. I mean, I guess you could like feature gate it and then say like the previous behavior is deprecated and give people time to transition over. But it would definitely, like today, if people create the PVCs and the stateful set adopts them, right? They use the name to map it up. The behavior they get is, okay, it remains inconsistent. And I think the thought of the original KEP is that if you patch that, then the expectation would be that you patch it through. If we believe that the stateful set controller should fully reconcile and that in the event that the volume is inconsistent, it should block, that would have to be implemented as a feature gated semantic in and of itself, because it's not the behavior people get today. And I don't even know if like moving that to default would be challenging. The one thing that we're running low, we took this a little bit longer than half an hour, and I don't want to cut it short, but if Philip is there, do you think we can have a constructive conversation in 15 minutes for your topic, or do you think that we have to defer till next meeting?
Yeah, that depends how deep we go, but I think we could discuss the important parts.
Okay, so Julian, I think definitely, like, it doesn't sound like from the chairs we have general consensus that this is like there are definitely concerns. I think we can continue to follow up on the KEP itself and see if we can come to a conclusion collectively about what the best path forward here is. But I think we should pause the live conversation now to give Philip a chance to present, and then go from there. Does that sound fair?
Yeah.
Okay, thank you. And thanks for presenting and coming. Okay, Philip, I'm going to.
Yeah, I think I do not need sharing. I will just discuss this.
Okay.
So yeah, I have presented this the evacuation API meetings ago. So there has been some minor changes, but last time or the feedback I mostly got is on the API that to explore the alternatives. Just so to reiterate, so people catch up, the evacuation API is similar to eviction, but it is asynchronous, and we basically strive to support like different strategies than just what the disruption controller does, that it evicts a pod. So we want to support different kinds of strategies that can be implemented by different actors in the system. So we achieve that by creating creating a declarative evacuation object, which can then the relevant controllers or actors subscribe to, and they can get scheduled for the evacuation. So the advantage of this is that we can implement, or not we, but anyone in the ecosystem can implement graceful like eviction or evacuation of any kind of pod. In the KEP, our main use case is single replica applications, which up to date did not have a PDB support and are important in many scenarios. And also the evacuation is can be used as a building block. So we have a follow-up for this, which is the known maintenance, and also there are two open issues that would like to use the evacuation API, which is a rescheduler and note of an affinity descheduling, which is coming up also. So yeah, and also one important part is that as we can see in today's many drain solutions, which is for sure kubectl drain and cluster autoscaler and many others, then there is this reconciliation logic for eviction that is implemented in many places. So this API, if we cannot find a evacuator who will implement the evacuation itself, that it has some strategy to either migrate or terminate the pod from a node, then we will fall back to the eviction. So, and we will have a reconciliation loop for eviction, and we have a good observability through the status and the metrics. So we can have a agreed upon approach for eviction. So we can observe the retries, and like a lot of the controllers that are implementing eviction today could use this feature to actually have it implemented in the core. So the main problems, or the discussions we had were if we can implement this using the existing constructs in Kubernetes today, which is mainly the eviction endpoint and the PDBs. So I have discussed this in the CAP itself in the alternative section, and like basically the full use case we are trying to achieve is it's not possible today since eviction itself is synchronous, and we need to store the asynchronous or we need to store the intent to terminate the pod without actually terminating it. And today also many people are overriding the eviction webhook, so this also hampers the functionality and the adoption. So, and it's also not easy to track these eviction requests through the pod disruption budget itself. And yeah, so do you have any questions or follow up I should answer or?
The new section that you introduced in the alternatives was for declarative node maintenance or for the evacuation API?
The evacuation API. So there is a short run for the eviction sub-resource, and for the enhancing pod disruption budgets, I can link it if you want.
So I'm looking at 4565.
Yeah, 4563. All right, I can paste the link. Yeah, here is the part which is discussing the pod disruption budgets. So basically, like the main problem is to solve the concurrency of the whole process. So we have like multiple entities which are, for example, it can be like like some drain controller, which we are also suggesting to be the node maintenance controller, but there are many others. So you have many drain controllers, then you have descheduling and many other actors that would like to initiate the eviction itself. So this is from the instigator side. So there could be a race there, and then we can have multiple like entities that would like to implement the actual evacuation. So for example, we could implement one in the deployment controller, and we also discussed a use case with HPA that could be like a fallback. If there is no better controller than HPA, then it will fall back to HPA, and HPA will, according to its setting, will scale up the pods to actually to prevent like any loss of availability.
So your primary thesis is that you can't linearize it. Like you need to make it asynchronous and you need to store an intent, but you can't do that because the eviction API is synchronous.
Yeah, so you just fire a request, and you, like at the end, like there is expected there will be a termination of a pod if it is not under a PDB. And that's the expectations of the clients, even though these expectations are broken and it is causing problems also.
Okay, fair. I need more time to look. I did not get a chance to really look at the update to the alternative section. I personally need more time to look at it, so I can't give you feedback in this moment, but I will give you feedback. Majek, did you have anything?
I need to have a closer look at the eviction API. I was looking at the cap. It was a little bit big, and I was leaning toward to what you and Clayton were talking about there a month ago in the meeting. I'm not sure if the alternatives, and I remember that was being discussed, if the alternatives were covering the topic of using pod conditions and how we could reuse that kind of functionality where during the eviction, if we have a PDB that is blocking, we would set a condition on a pod that the owners could react by moving their workload and unblocking, because if I remember correctly, the primary problem, at least for the single replica application, was that there is no option these days. Well, theoretically, other than from listening to the eviction API and then reacting on it. I was also considering what if we would change the semantics of the eviction, that it would not be a one-stop point, but rather you should be able to retry eviction a couple of times in a row. And eventually, after the first invocation, we would be able to react, move your workload, and then one of the subsequent eviction requests would basically succeed, allowing you to move the workload further. So those are the things that I would try to look a little bit deeper into, and I need to find some time to do so myself and dig through deeper through the eviction API and what we currently say, because I don't remember if we explicitly say that, oh, you can only try to evict something once. So I would probably try to do some kind of looking around that, maybe expanding the eviction API with a response where you would basically say, I failed this time, but in the response, you would be able to say, but you know what, return in another 30 seconds and retry that kind of an option or something like that, which is, I think, Clayton was talking about having a pushback mechanism, although he was talking specifically about PDB, but I'm not sure whether that will be driven by PDB or maybe somewhere within the eviction API. So those are the thoughts that are flowing through my head. I haven't crystallized anything yet concretely, but I'm inclined to start a little bit smaller than doing a major revamp of that API. And I'll shut up because I see that both Ravi and Philip have their hands up.
Yeah, I can let Philip go first. Like, Philip, if you want to answer that, that's fine.
Yeah, just shortly. So yeah, if like I still don't know if we could break the expectations that are today, like regarding the eviction API, but suppose we could, that we could like change the API to return the like some error code or something, that something is in progress. Then like we have the first issue, as I said, that people are overriding the webhooks, so the request does not always pass through. And the second one is that this runs into the problem of the concurrency of the evacuators. So like we have tried to like implement this through the pod status, and I have discussed this with David Eads, and he also said it's not a good idea to have multiple actors to raise for the pod updates. So that was the initial idea, and that's why we moved to a separate object. And also, like, it's hard to achieve a good observability of this whole process. So there is not clear, like, how to observe who is doing the eviction or the evacuation, and how it is progressing, and who are all the actors, and what can go wrong in this. Yeah. Okay, Ravi.
Yeah, I think we are slightly over time, but I just want to call out that we had similar issues, and I think I was chatting with Philip and Ache as well, like late last year. And the way we have sort of solved the problem, again, like I think we did not solve the entire set of problems, but sort of solve the problem is having some sort of extension mechanisms to PDB where we have multiple entities which you can register in the in the API. You can say that these are the extenders for the eviction, and we will call the extenders one by one, and they would actually be responsible for setting the status back, saying that the PDB is successful or not. We had to make some changes to the API, and we also had to make some changes to controller, but this would be similar to what Kube scheduler does with a set of extenders when the scheduling is like we have various phases in the scheduler. We can say that during the preemption phase or during the filtering stage, you can actually go make an invocation to an external entity that actually gives us some control over which entities can actually make a call whether the eviction can be successful or not. So like I'm saying that again, we have not solved the entire set of problems, but those extensions have been helpful to us.
Yeah, and I mean, like, but the kind of difference here is the extensions are much lighter weight, and like they're designed in such a way that even if I write Volcano, like if I'm using another scheduler, it's easy for me to adopt them and leverage them going forward. The hard part with the evacuation API and the declarative node maintenance, from a conceptual standpoint, what seems to be a little bit contentious is that it's a lot of APIs and it's over like it's it's like almost deprecating the existing ones as opposed to interacting like with the existing components in a way that's very low touch, right? That's kind of
We use PDB, like we do not use any of the other APIs that you have mentioned.
Ravi, do you have a write-up, or are you willing to present the solution that you've implemented with
There
those
is some,
extenders?
I mean, like I can write up the proposal, but I cannot open source it at this point of time.
No, I mean just writing down the
Sure.
approach that you took, outlining the problems that you solved and the solutions. I'm not saying that you have to entirely open source the solution that you have, but just sketching what the mechanism you have.
Sure.
It doesn't have to be a full-fledged CAP, even just a document, so that we can have a look at and maybe drive the direction of the work that Philip is trying to put together.
Sure. Yeah, I can do that.
Okay. And as Robbie mentioned, we are running a little bit over time, so we can follow up offline. I want to respect, people's time in the meeting. Thank you all for attending. Thank you all for presenting, and we'll see you in a couple of weeks.
Thank you. Bye.
Thank you.